Now that we've seen completing the square and the quadratic formula as the solution methods of solving quadratic equations and how they work, let's see how they're related. So what I'm going to do here is I'm going to take an equation, quadratic equation, general quadratic equation, and I'm going to do completing the square on this quadratic equation. Here, of course, a, b, and c are some numbers, and we'll demand that a is not equal to 0. If it was equal to 0, then we just have a linear equation because this term wouldn't be here. And let's go ahead and complete the square. So remember, when we're completing the square, we need to be of the form x squared plus something times x equals something. So since I need to turn it into this form, I'm going to move this plus c to the right-hand side, and then I'm going to go ahead and divide by a. So that would leave me with x squared plus bx equals minus c, and now I divide everything by a to get rid of the a on the x squared, and I get x squared plus b over a, x equals minus c over a. Now remember, this is just is going to be some number if you're working some problem, and this also will be some number. So now that we have that, let's go ahead and draw our geometric interpretation. So the area of, let's see, x squared, that's a square with side length x, plus the area of b over a times x, so that's going to be a rectangle, b over a, and the area of this has to be equal to negative c divided by a. We'll go ahead and split this in half, move this right-hand piece to the top here, and if you do that, then the length of this new rectangle is going to be not b over a, but b over a divided by 2, which is b over 2a. And so we get that we have a rectangle on top, a square, and a rectangle on the side. This is x, 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 b over 2a, b over 2a, and x. And the area of this shape has to be equal to negative c over a. Let's go ahead and complete our square on the left-hand side and add whatever area the square has to both sides. So the area of that square is b squared over 4a squared. That is b over 2a all squared, which is b squared over 4a. And I guess I need to square this a as well because I have this squared. And now I have the area of this large square on the left here equals something. So let's go ahead and write out what the area of this large square is. The side length is x plus b over 2a. Area is side length squared, so this is going to be x plus b over 2a squared. And that's going to have to be equal to this right-hand side. Now this right-hand side, I think what I'll do is I'm going to get a common denominator here. So one denominator is a, the other one is 4a squared. So if you multiply both the numerator and denominator of the first term by 4a, then this denominator on the first term on the right-hand side would be 4a squared. And so the whole term on the right-hand side would be b squared. I'm going to write b squared first, then minus 4ac, all divided by 4a squared. Now remember, a, b, and c, they're all some constants. So in a problem with numbers, this right-hand side would just be some number. And we have an equation which says something squared equals a number. So we can solve that by taking plus or minus the square root. So x plus b over 2a would have to be plus or minus the square root of b squared minus 4ac all over 4a squared. And one nice property about square roots is that if you do the square root of the division, it's just the square root of the numerator divided by the square root of the denominator. And so I can rewrite this as x plus b over 2a equals plus or minus the square root, and I'm going to write one square root over another square root, and the denominator will have the square root of 4a squared, and in the numerator we'll have the square root of b squared minus 4ac. And the square root of 4a squared is just 2a. So this is plus or minus the square root of b squared minus 4ac all divided by 2a. And that has to be the same thing as x plus b over 2a. And now I can go ahead and subtract this b over 2a, that is, subtract b over 2a, and I get x equals negative b divided by 2a plus or minus the square root of b squared minus 4ac all divided by 2a. And combining these two, because they both have a common denominator of 2a, I can combine these fractions. I get negative b plus or minus the square root of b squared minus 4ac all divided by 2a, which of course is the quadratic formula. And so I suppose the conclusion would be of this discussion is that the quadratic formula is simply taking a quadratic equation and completing the square and seeing what formula results. So you take your quadratic equation, you apply completing the square, and you arrive at the quadratic formula here.